Good morning, folks. I would perhaps say congratulations for finding the fourth floor, but you were all here and I've just walked in, so we'll just go with that one. That's fine. So, DFMA, Design for Manufacture and Assembly. I think the starting point always with lots of presentations needs to be actually just defining what we actually mean, because we are really good as an industry of rushing off with terms, acronyms, all the rest of it, and not necessarily having a common understanding. So, Build Offsite is an organisation that Trimble are members of in the UK, and have done a lot of really good work in terms of defining and providing case studies and a whole load of other information as to what offsite can be. And they've divided it into 4 levels, because predates BIM levels, but hey ho, let's get ourselves confused with all that. Starting off with just at a component sub-assembly level, and these various opportunities of what you might do as an offsite solution at a very simple level. So an individual structural member or an individual light fitting. It's sort of that basic point of we don't make bricks on site, we buy them in by the pallet, but that sort of minimum level of what offsite might look like. Then it moves up to a non-volumetric pre-assembly title, and again we're starting to look at individual sort of flat panels or those sorts of things rather than actually filling spaces, but to make life again simpler, that something is precast or pre-manufactured off-site and then can be brought to site and then installed in place. And again, that word assembled rather than constructed. By the 3rd level, we get up to volumetrics, so looking at hybrid solutions, pods, all those sorts of things. And then finally, level 4, complete buildings, built in a factory, put on the back of a wagon, brought to site, plug and play, and off you go. And for us, for the bit of the Trimble business that I work for, which is predominantly selling Tekla software to the structural market, we see huge amounts of where actually BIM and offsite link up together, because all of those bits we think actually work for the structural market. So, principles, how do we set about understanding where we go? Well, principles for DFMA, it talks about minimising the number of components. So again, this is where some of these implicit lean theories are. What is the best way of putting together bits, things, stuff, off-site, bringing it to site and assembling it together? Things need to be easy to put together, even if it's in a part fabrication process, and then you can carry on and finish it off. But you need to understand tolerances. How well do things go together? Is somebody asking for fractions of a millimetre assembly tolerances, or are they happy with 10-15 mil? Can you work with both? You need to understand them. And probably understanding tolerances is the most important bit, and a lot of issues on site come down from people not understanding tolerances. And then clarity, which is a really important one as well. You need to be able to put the components together in one way. This isn't quite Lego, where you can come up with all different versions of a spaceship. The custom has asked for a specific asset, and the components need to assist you to put it together in that one way. And all of those, BIM allows you to improve on those processes. So it helps you define what your components should look like. It helps you how to make fabricated components. It helps you to understand those tolerances, and it gives you that clarity that you can only put things together in one way. Furthermore, second part of this DFMA principles that talks about removing or minimising the use of flexible components, which is an interesting sort of point, but I kind of get it. It's probably not the most major overall. But it particularly talks about design for ease of assembly, and this is an image taken from Bryden Wood's work with GSK, where just colour coding the connectors makes it very easy for people to understand how to put things together. If you think of IKEA brochures, if you think of, again, Lego catalogues or whatever, it tells you the colour of the component you are looking for. We should have an example a bit. No, that's my other presentation. In Tekla, within the rebar modelling, all the different bar diameters are different colours. So again, you could have tags on the rebar that says, right, I'm looking for a T25, it's magenta, therefore I look for a magenta tag, and it starts to speed the processes up. So you're thinking about making people's life easier for assembling the process. And it also talks about things not having adjustment. So again, whilst you need to understand tolerances, you also want things to fit together. Again, think IKEA, think Lego. It goes together, it snaps, it clicks. There isn't sort of any looseness or whatever. It feels solid and sound. And again, in all of those things, our digital processes can help us to understand how to improve these things. So in the UK, like lots of things, offsite is not a new process. First report way back in 2005, it even predates all our BIM reports. But the government was talking about modern methods of construction. The construction strategy for the UK in 2013 cited offsite. KPMG wrote great reports about it. Then the government wrote another strategy saying that we needed to do it, and the RIBA produced a DFMA overlay, which we'll talk about a little bit more because I think it's a really useful document. For those of you that don't know, Mark Farmer was commissioned by the government, wrote a report with the catchy title Evolve or Die, and the construction industry, like the construction industry does, probably generally chose to ignore it still. Bryden Wood have since written reports to actually again help the industry to understand how to actually adopt offsite manufacturing for buildings and infrastructure projects, so that there is a place in linear infrastructure as well. And then finally in the UK in 2017 we had a statement from our government saying the presumption in favour of offsite construction by 2019. So in theory all of the government centrally procured projects should be going and considering offsite as its first choice. Whether it's really happening, not sure. We then had all our industrial strategies, the main construction strategy, and then various subsectors for rail and nuclear, and yet further reports telling us that actually offsite was the way forward. So there's a huge trance of evidence that says there's benefits, and the industry really kind of needs to get its head around it, whilst also accepting that actually there is good stuff being done. It isn't that there's nothing. So the key one that came out from all of those reports was actually an even more nuanced, no, probably not the best term, but a development of DFMA called PDFMA. Hands up who's heard of PDFMA? Good, that's brilliant. That means I can just say anything and you'll believe me. Okay, platform design for manufacture and assembly. And again, this was taking the idea of offsite manufacturing and those standardised components to a whole new level. Again, it was another report developed by Bryden Wood with the University of Cambridge. And this platform design approach is where actually you buy a lot of raw materials in the size and shape that it comes and accept that that's the way it is, and the clever bit is in the connectors of how you put it together. So one of their examples is, rather than in the structural steel market where you might buy column sections and then get them fabricated with end plates in a factory, paint them, send them to site, that actually you buy direct from Tata rather than from a merchant stock steel, send it to site and put clever collectors on it on site to put it together to create the frame that you want. It was at the time it was produced back in November, there was a big fanfare saying this is the answer, it will solve everything. I think there's been a little bit of a reining back and understanding, but there's some really powerful thoughts to sort of again disrupt and rethink construction as to actually what is the right way to go forward. So probably of all of those previous documents, I think the Platform DFMA document is worth a download and a read and see where it might go. So, mentioned earlier the RIBA Plan of Works. So back in 2013 in the UK, again, the RIBA produced a new digital Plan of Works with, instead of the stages A through to M, which we all kind of knew and understood and argued where end of estimating came in and project procurement, all the rest, this one had stages 0 through to 7 and is a much better tool in terms of actually at stage 0 getting projects to think about the strategic definition. Do you actually need a building, or do you just need to space plan your building better? Picking up on Sandra's points from the lady from IBM earlier on this morning, right through to actually thinking about how you use the building going forward. So it's a really powerful document. It also, again, you won't see it on the words, but the third row down has suggested BIM tasks. So again, it's considering how you do things digitally through all of this process, embedding BIM as business as usual rather than necessarily being some add-on to the process. So to try and understand a bit more about how that works, again, hands up so you don't all fall asleep before lunch. Anybody heard of the McLeamy curve? Okay, so McLeamy is an architect in the States who produced this curve which lots of people now cite, and this is my interpretation of part of it as well perhaps. So basically, as you go through the progress of a job, your ability to impact cost gets harder and harder. right at the very start, very early tender design briefing stages, you have lots of opportunities to make big decisions that won't really cost much in terms of rework or whatever, but allow you to make a decision and deliver the job. By the time you've got to that build phase and the engineer or the client or the architect, whoever suddenly says, well, actually, I'd like the building the other way round, the ability change becomes much harder. And equally, the cost of those changes therefore rises dramatically. So what you have in a traditional design process is information that's sort of produced in that way. That there's this sort of big hump and lump of information at design stage, but there's still bits of design being carried on in that build and commission process. So again, for those of you that know and love design and build, or build and design, as lots of the market tends to do it, you are sort of permanently on the phone to the engineer, to the architect, saying, I haven't got this detail, I don't know how to finish this bit off, how do we do this stuff? And what McLeamy proposed was that actually a preferable design process was to bring the design forward. So you do the rump of the design work in that concept and definition phase. So while you are trying to define the scheme, you also design the scheme. So that by the time you get to site, the scheme is fully designed, fully coordinated, everybody knows what they're going to get, and then your supply chain delivers what you are expecting. Similarly, the RIBA plan again suggests that if you're going to consider offsite DFMA, that stage 2 is the time to do it. So it's in alignment with these documentation from the States. But I think what you've also got here is there is that little triangle, or not so little triangle in there, between those two curves of basically for designers, that's the time you're going to expend doing RFIs. Sorting out all the problems on the phone and all the other things when the contractor's shouting at you on a Friday afternoon saying, how on earth do I finish this off, I'm pouring it tomorrow. But not only is that sorting out RFIs, that's your fee profit. Because you designed it once, and you aren't expecting to design it 3, 4, 5, 6 times during the course of the build process. So if you can get rid of that delta, that's you protecting your fees as a designer similarly. So why on earth would you not consider a new fee profile, taking that curve 4 that says actually, let's move it forward, let's think about maximising off-site assembly, but also having a complete design. And that might mean you need a conversation with your consultant, with your client to understand these processes, explain those sorts of benefits, show him these graphs, all that sort of stuff. But again, driving the idea of actually let's think about offsite and let's think about BIM processes to bring the design forward. So rather than having this sort of traditional design and on-site solution with a construction phase, or more likely a construction and design phase that's still bleeding into the construction, that we can take an off-site solution, reduce the design period, definitely reduce the construction period because our off-site manufactured solutions will be installed quicker, and again, there's some more profit. Even if it's only your prelims that you are down on site for a much shorter period of time. So we've got two benefits there. The red square of extra profit from prelims and the purple triangle of extra profit because you're not having to spend all your time finishing off a job. So, going back to the overall plan that the RIBA came up with, it talked about these 8 stages, and the DFMA overlay equally uses those stages and then produces this template, which is a really good guide to explain what you need to be thinking, what reports, what strategies you should have in place at each stage. And as I've already mentioned, it talks about the BIM tasks it suggests that you should be doing through the process. So we'll quickly rattle through, conscious of time, the 8 stages and what DFMA might actually bring to you. So, stage 0, identifying the client's business case and strategic brief. Fundamentally, do they even need a building, or is it space planning the one they've got? So in the DFMA overlay, you analyse data from existing buildings. Again, probably coming back to some of that IBM Watson conversation from Sandra earlier. Do you have data about actually how you use your existing assets? What is your real need? What is that ultimate drive of why you are trying to do the project that you want to do? So starting to think at that high level in BIM terminology of organisational information requirements. What is the information that allows you to work as a business? Can you actually gather any cost and programme data from previous projects? Do you know what worked, what didn't, what works well, what doesn't work so well, what you want to do again? And have you got any perhaps object libraries of components that you are wanting to use as a client or specify on the project that you think, well, actually there will be benefits in having the same door across the portfolio of 30 buildings rather than different doors from different suppliers with different ironmongery. That means that my facilities management team do 3 visits to every door to change a handle because they'd never know what they're going to come up against. We then move to stage 1, and we talk about developing the project objectives and quality objectives, program outcomes, all these sort of high-level documentation of what is it we want to do that set the benchmark for the scheme, so that when we get to stage 7, we go, why have we got a circular building when we said we wanted a square one? Where is that audit trail along the way? Were we wrong when we set the brief at stage 1 and we have an audit trail to explain it, or what on earth happened? For DFMA, in terms of stage 1, looking at feasibility studies and using placeholder objects. So again, you detail as far as you need to. I need a column, but it's just an indicative placeholder. At this stage, I don't need to know the exact size, so let's not overproduce data to actually expend money to make waste into the process, but understand where the cost information about that sits. Use BIM to test the brief, so whether that is playing around with mass modelling and looking at room layouts and all those bits and pieces, circulation, how you can actually do a digital rehearsal of the scheme. Is this now going to deliver what the client wants? Explaining to them, yes, it might not look that colour when it's finished, this is just grayscale, but just to say, is this the sort of feel of what you want? And then you need to prepare some sort of design responsibility matrix. We're not doing all of this outside of contractual relationships. People need to be responsible for what they are doing. And then in terms of procurement, and this is a really important image here for me, as it's one of our customers, but it's also McAvoy's, so over here as well, so really important in that respect. But to start to think about actually how you do your procurement strategy and how you build the most efficient scheme. Now, this is a project developed with the Manufacturing Technology Centre in Coventry called the Seismic Project that McAvoy's were involved with Elliott's. And again, this is saying that actually if we can use standard components for all of the cold rolled forming, but have some really clever connectors, then actually the industry can move forward. And by this way, you can actually start to move together volumetric assemblies from different manufacturers, and they fit together because all the smart stuff is happening in those red and green connectors. So again, thinking of different ways of putting the construction forward. We get to stage 2, and yes, we need to start developing that model so that we actually know a bit more about the spatial relationship. So again, we think it's probably concrete in this image, might still be steel. We're still making those decisions. There's commercial decisions to be made, but we know we need some sort of volume and space to put the structure and the frame into it. Validate the model. Have we actually got what the client asked for? In that scenario, why have we got a round building when we started with square? What is it that they're asking for? Which standards are we working to, and how do they make that work going forward? And then look at the tolerances again involved in the modelling and also the construction of the process. Now, stage 2, as we said earlier, that is the stage that we need to be doing all of the real work to maximise off-site. By this stage, we've got that concept design. We know what we want to do, what the outputs need to be, and that is the point to press the button and say, right, we need to drive down an off-site route, because if you leave it any later, it will become progressively harder and harder, and when we go back to those Cleamy curves, the ability to impact the design gets smaller and the impact on cost gets bigger. So those decisions for the customer, while he needs to be thinking right at the strategic brief and preparation stage of, well, do I want to do this offsite or not? Look at the options. They've absolutely got to make that decision by stage 2 if they really want to drive the benefits. By stage 3, again, the components are starting to become more understandable, comprehensible, and become looking more like manufactured objects. So not only does this column in the precast case need to actually stand up from floor to floor, but we need some shoulders to it so we can actually connect beams onto it. So we understand how these things are moving forward, and design responsibilities are clearly defined. So we can use our digital technologies with our digital models to actually look at that coordination and understand, right, how is this thing going to fit together? Can we do that construction rehearsal, even at stage 3 with the design team, to have an idea of how we're going to put the project together? By stage 4, we need a far better design. But this is at stage 4. We didn't need it earlier on. So rushing off at stage 1 and doing a fully detailed precast column, because you can bet your bottom dollar at stage 2 the client will go, actually, I think we want steel frame. Where are you going to recover your fees for all that work you did? But now you know it's precast and you know what it looks like. That's the time to start doing that detail. And again, doing that detail digitally so people can start to share the information and start to look at manufacturing offsite with digital information. And not just the manufacturing, but the construction strategies, so 4D, the timescales, the Gantt charts, all those bits and pieces, bringing these data sets together to understand, right, okay, we are manufacturing, we've got manufacturing processes going off-site, and the logistics and the assembly process is happening on-site. Get to site, we can use the BIM processes that we've got, the BIM data that we've got, to actually allow people to understand how they're going to build the stuff. So whether it's using virtual reality, augmented reality, mixed reality, any other reality somebody wants to come up with, but all those sorts of things to actually say, right, there is a rebar cage, and you need to go and pick the red bars, and then you need to go and pick the green bars, and then you need to go and pick the blue bars, and this is how you put it together. And if you actually can be interested to come back and see my mixed reality presentation this afternoon, you'll see some examples of where we've done that. I've managed to get a sales pitch in for my second presentation. That's got to be good. Okay, but again, using digital technologies to track the processes that you're doing. None of us now would expect, if we order something on Amazon, to not know almost within the hour when it's going to be delivered and by whom. But on a construction site, we're still happy to probably rely on a truck driver possibly pulling into a service station and go, I'm late, if you're lucky, or else he just doesn't turn up. We, in our personal lives, we accept digital data very easily and we just work with it, and that's what we want as a customer experience, a user experience. And then we're quite happy to not have that same level of customer service in our construction world. It's very strange the way we do this still. Looking at how we record records, how we record data now, that's obviously a very powerful little bit of PDA, but the amount of stuff that you can do on your mobile phone with applications and all those sorts of things just to actually make it something that's familiar to people. Get to stage 5, we're working through, we're now starting to do all the work on site, tracking all the defects that hopefully we haven't got because we've gone for it off-site, and at stage 6, we're then handing it all over with that digital information. And I'm going to rush through that one because fundamentally at stage 6, it's just about handing over information, which could be more important than the physical asset. And stage 7, we look at actually how we utilise the models that we've got to bring that data into a system to actually monitor the use of the building. So a big data wheel going round and round and round, and finally conclusion to get myself somewhere back onto time. So benefits of DFMA, this is coming straight out of the report from the RIBA. 20 to 60% reduction in construction programme time. Why would you not want that? Greater programme certainty. 20 to 40% reduction in construction costs. Again, why would you not want it? 70% reduction in on-site labour with improvements in health and safety. Some of the stuff that we hear that Trimble are doing in the wider business in terms of autonomous machinery and all the rest of it, just remove the entire need for people on site for their own safety. And then reducing the need for skilled labour on site. It's a moot point. Obviously, yes, we've all got the construction skills shortage, but actually we can find better ways to deploy people in better places going forward, and we get that better quality. We get better environmental outcomes because we've reduced waste, whether that's physical waste or time waste. And we get those fewer queries from site, that bit where your fees are being driven away. So in the UK, the government's going down this route of standardisation, and for me, as an overall summary then, we've got digital processes definitely have a part to play in all of this because we get accurate data sets so we can make better decisions. We get 2D documentation, don't ignore 2D, it's still a vital part. It doesn't necessarily need to be physical 2D, but 2D documentation to improve our commercial, contractual, health, safety, quality, all those procedures, but 3D to enable us for the better coordination, collaboration and engagement. So why are we doing DFMA? Because we've got proven improvements in time, quality and cost. Why are we doing BIM? Because we think of it as better information management. That's been used as a phrase this morning as well. But it also helps to align our decision making to maximise our off-site processes. We should be able to get down to 0 RFIs, that the scheme is designed and then you just assemble it. So why together? Because you're going to improve your bottom line of your business. And that's me.
Well done.